Good morning, everyone. Welcome to the EasyPower Tuesday Refresher webinar series. My name is Jim Chastain. EasyPower's done a good job of making the utilization of motor control centers and panel schedules and very intuitive, and so very little time is needed to get up to speed, if you will, on utilizing those capabilities. And so we don't talk that much about them in the webinar series. Today I'm going to be dialing into some finer tuning of those capabilities, and hopefully you'll be able to get some nugget of information that's useful to you. First of all, we'd like to start with a poll question of basically how often would custom schedules for panels or MCCs be useful in your projects? No right or wrong answer, strictly just what your opinion is. And apologize for misspelling custom, or it depends upon which side of the border you live on. As always, we will be sending via email an attendance certificate noting the time that you spent in the webinar today. People use that for supporting EAU claims. So it looks like we're close to a quorum. Here's how people have weighed in. And I'm pleasantly surprised that there's a higher use or need for custom schedules. Thank you for reporting that. And then secondly, how often do you repeat the loading for panels or MCCs as far as the loads, breakers, the like? Again, the ability to have to re-enter all the data for a panel is kind of what we're aiming at, or at least I'm trying to divine. So we're about halfway to a quorum. Let's leave this open another 10 seconds. All right. Thank you for responding. Here's how folks have weighed in. Again, I'm pleasantly surprised that the numbers reflect an interest in what we're going to be spending time on. So good. Basically, everything I'm going to be going through, there's nothing new as far as features that we're going to be covering today. And so even if you have an older version of EasyPower, with these modules, most of what I'm doing is going to be in the database editor and then some utilization of the optional auto design module, all of which could be done manually. And I'll point out where I'm doing it for time savings, but I want to establish some reusable configuration options. One of the features is called library load. And basically by setting up a spreadsheet one time in the device library, you can utilize it to preload or more rapidly load up new MCCs and panels. We'll be going through that in detail. And then the need or the potential for saving as a subsystem pre-configured panels and MCCs is relatively common. And then after that, we'll be getting into customizing the schedule template that's used to display the data. And in particular, we'll be adding short circuit and arc flash information into that schedule. And so those of you with short circuit and arc flash can be able to take advantage of that. Now, again, this is not recommendations. These are not authorizations for specific procedures. What I'm about to show may not fit everyone's preference. And so that's, again, kind of the caveat that I go into this discussion with. So first of all, we're going to add a library load capability, which means in my device library, I've created a subsystem or a subfolder under both MCC schedules and panel schedules that I've identified with some one-time entry that then can be reused in my one line as I use these loads. And you'll see how this speeds up the possible utilization of panel schedules. Now, in a device library, we can create a new schedule. And as we do that, we fill in the load, we give it a name that we want to be able to identify it, and then the load type. And most of this data entry is very similar to what a typical panel entry would be, including calculating the load for the motor size and isolating the number of buses that's used for that particular load. And so this is specifically in the MCC schedule. And now that when you set this spreadsheet up, you can then reuse it to populate your icons when you start your one-line diagram. So the typical workflow is once you've created the library load in the device library, you can then utilize it once you've identified that connection in the device library to fill in your setup. Now I'm going to use auto design to be able to size the cables properly because frequently the one component that we won't know when we set up the library load is the length of the conductor to the load that we're going to be identifying. So in my auto design, I've specifically set up a pointer to use the Square D 2007 catalog because that's the type of breakers I'm using. And then I want to make sure that I'm sizing the breaker once I've established the load, and you'll see how that can be done automatically when I get into the tools. So let's jump into this and let me kind of show you what I'm talking about. So if I go into the device library, again, this is all information, this is all available features that have been in EasyPower for a number of years. And I've already established a renamed copy of the standard lib, and that's where I've entered my spreadsheet for both panel schedules and MCC schedules. And so you'll see, as I've done this, I've described the motor load, and this is just a matter of typing in the data and then filling in the details as we go across the page. And you'll notice that I've established my breaker type and manufacturer and style as a prerequisite, and then I haven't necessarily entered or connected the device library to it, which is a function of the interrupt rating. And I'll do that after I populate the MCC or the panel. All right, so here's what we're going to do. We're going to start off with the panel icon. And I'm in the three-phase palette. I'm going to put an MCC icon on this side. We're going to populate some loads. Okay, again, now this data, designating a three-phase 480 volt, I haven't indicated what the manufacturer is, but I have a bus rating of 400 with 400 amps with an interrupt rating of 42,000. These are default settings that I've set up in my device library. So they're coming in with some information. I'm going to utilize main lug only just to simplify the auto design process. And let's put in 6 rows of loads. I'm looking at the left side. Now I need to identify that spreadsheet that I created. So because I know it's in the device library, I'm going to pick up the one that I was pointing to. And now let's say this is my chiller pump. And from my device library, I know it's an HP motor, excuse me, a 10 horsepower motor. And then as I tab across, you can see that data that was in my spreadsheet now has been populated. I'm going to go ahead and put in another motor here. Let's call this the sump. And let's identify that as a 20 horsepower motor. Tab across. As I can reconfigure this spreadsheet, this schedule, by isolating on it and then changing my spreadsheet view. So what I've done is I've reduced the number of columns that I'm looking at so I don't have to scroll so far over. But when I get to my protective device, you can see I've already had, this was selected from my spreadsheet. I have auto calculate set up, so it's connected it to the device library for the interrupt reading. Now I know the length of conductor now for this particular motor is 155 feet, and this one's 85. Now what I want to do is use auto design to size the cable based upon the length and load that we've stipulated. So I can enter that manually, or I can right click on auto size using auto size. It says it was sized effectively. And as I scroll over to the conductor, you can see it's rated for 30 amps and it's a size 12 AWG. So I'm going to do the same thing on my second load. It says it did it properly. And again, here we're talking about the sump pump. It's been sized with the number 8 AWG, and it's a slightly larger. Now, let's say for now, this is all the load I want to stipulate. I can go ahead and put in say a fixed load for the right side. Let's say it's heaters. And my heaters are a 10 kilowatt load. As I tab over, you can see it's spread out the 3-phase VA phase loading. Again, we have a 4-aught. Actually, I haven't specified in my conductor size. So if I put my length in here, let's say this is 200 feet. I'm going to right click, auto size it. And it set us up with a number 12 AWG. Now, once I've populated my load, and again, this is relatively easy to change or to expand or to even jump and delete or replace. I want to go to summary, calculate the downstream load, go to OK, and now my panel's been loaded accordingly. Let's do the same thing for the motor control center. Open up the motor control center icon. Again, there's some default settings that I've saved in my setup for 3-phase motor control centers. I'm going to use main lug only, although I could change this and it could be part of my setup. Let's go ahead and set for 3 loads here. First load, let's say, is exhaust. I went the wrong place. Exhaust. And then my library load will be coming from, I need to make sure I'm pointed to the right. Spreadsheet. Let's say it's a 100 horsepower motor. And the next one is, let's say, a recirc. So it's got to be in my setup sheet before it's going to understand it. And let's set some heaters over here. Tab across. Now here we have the possibility of changing the load description, the load location, the schedule listing, the section space, so it can do the elevation for us. And right now I want to look for my conductor. And the length to this motor is 200 feet. Let's say this is 55. This one's 125. Now, you'll notice it didn't bring in a conductor size for my linear load. So let's see what happens when I auto-calculate. Let's go ahead and do all three. Now again, this is an optional module, so this can be done manually as I bring it in or as I enter it into the library load here. So we have different ampacity ratings, we have different lengths and different size cable. If I'm happy with all that, then I'm ready to go to the summary. And we're going to calculate the downstream load. If we have any sub panels or sub-motor, outboarded motors, and then calculate the X over R. Now I've got in my workflow options, I've got auto calculate set. Normally I manually calculate. So at this point, we want to go ahead and auto calculate this or auto design these based on the load. And okay, it's not coming up with let's see what our auto design standards are. Size everything, lines, protective devices. Okay, it should go. Let's see what's the effort. Now I'm selecting just the cable and the breaker. If I auto design, it should size the breaker for us based on the load that we've put in here. So for some reason I'm not getting a response over here, so let's see what's going on. Oh, there it happened. Okay, so at this point, we're relatively happy with what's going on. We want to do a look at the schedule, highlight the schedule, highlight the icon, right-click, and insert the schedule. And again, this can be done on the main, or if I isolate in a separate drawing, and easy controls, I can insert the schedule here. Okay, so at this point, what I've done is been able to enter the data that was preloaded. Everything was set up for square D. I have my schedule results, and if I wanted to, I could save any one of these as a subsystem. Again, that's one way to save a preloaded or a repeat loading. And the way that is done is I want to go into New, Subsystem Template. I want to be able to copy and paste over to that. So I'm going to reduce the size of this window, which is the template for the subsystem. I want to left click and drag Control C, go back to my subsystem template, Control V. Now I don't have to include the cable, but in this case I did. And now I save this as a subsystem, just this top window. So save as, and I'll give it a name, MCC. Now as I go back to my one-line diagram, I can then go to Insert, Subsystems, and there's my MCC preloaded for reuse in either in this file or in others. Okay, so that's using library load and creating subsystems and auto design for resizing both the breaker and the cable. Now I'm going to jump into custom templates. All the templates use XML to create the format, and that can be edited by a notepad. I use Notepad++. You just can't use Word because it saves it as a different file structure. So make sure that you have the ability to reuse XML templates. All the templates used in EasyPower are in the template folder. There's separate ones for the MCC, the panel, and the switchgear. And these are found if I go to my default file locations under Options. These are all found in the template folder of the installed, in this case, EasyPower 10.11.0. And what we're showing here is that this is the standard template both for MCCs and for panel schedules. What I'm going to do is edit both with some XML code that looks like this, and then save it with a new name that I'm going to represent ArcFlash. Now, just as a precursor for what's going on, that a switchboard and, well, that's a good question. The panel board, so the question is there a switchboard template or a switchboard and switchgear the same template? To tell you the truth, I need to check on that and get back to you. Right now I'm showing switchgear template, and I think it's just a matter of nomenclature, but I'll follow up on that via email. Thank you for the question. Now, once I've changed this file and saved it as a different name, what I've entered here is slots for the short circuit results and the arc flash results. And if I'm going to use it continuously, then I change the file pointer under the options menu that we were just looking at. If I want to change it just on a temporary project, I do that at the project file. So let me kind of get back into EasyPower and show you what that means. So right now, I've already established the schedule. I've already populated both the MCC and the panel. If I were to change the pointer to the ArcFlash icon, which I have in my device library, it wouldn't change the existing schedules. But any new schedule that I built, it would change. Now, if I'm only going to use this temporarily or in this one project and not in others, I'd go to Properties for the file, and rather than go with my default, I'd specifically say I want to go with the device library in my listing that has panel schedules. And so I want to choose specifically the template for MCCs. In this case, it's going to be ArcFlash MCC schedule.emz. Now this, I'll be sending out a zip file, or I'll make a zip file available that has both of these, the MCC and the panel schedule in it. And you'll be able to populate your device library accordingly. But let me show you how it's going to work before I do that. So again, I'm looking for an arc flash schedule for the panel itself. And I'm going to change the panels that I've already set up. So as I go to open and apply, the tool says, are you sure you want to change the templates that are being used? So I'm saying yes. And now what you see is a template that has both the short circuit block and the arc flash instant energy block, but they're not filled in. So let's kind of recreate this. Here's what the original template, the standard template that's included with the installation. And here's the file that I've modified. It's going to show the short circuit, arc flash, and instant energy. If I go back into EasyPower, now so far I've just been using device editor, the database edit, and the auto design. Now I'm going to go into short circuit, and let's see where I messed up. Oh, I didn't size these links. So let's make these THWN 2-aught. THWN and 3-aught. Okay, now we're back going into short circuit. We're going to, under fault buses, I have the ability to fault the bus, which gives me the output or the data on the one line. I also have the ability to advance, under advanced, to fault and store. What this means is going to fault the bus and store the data in the device library. So with that, now we see, at least for the MCC, the short circuit available short circuit current. We don't see the instant energy yet, or the arc flash boundary, so I need to fault and store instant energy. Now we see the arc flash boundary, the instant energy, and a reference to the PPE designation. All right, I also want to go to my and we're going to do the same thing here. All right, so at this point now, I've been able to utilize the custom template, and it's also entered in my device library. So Chuck is saying if you use the panel board icon on his one line, he has a branch CB to the panel that's connected to another downstream load. So again, the icon that's picked up is going to have a default value. Let's look into this one. Let's go ahead and save all the changes. Go back to the main. Let me see if I can understand what Chuck is saying. He says if he goes into the one-line panel board icon on his one line, Chuck, I'm missing the point. Let's see if we. No, I think I have to take that offline because I need to play with. So whatever you're seeing has been set up by default, and it doesn't like this if I haven't entered numbers. So apologize for that. I will follow up post haste. You want to show cable out of the panel? Okay, now that's a good question. I like good questions. Chuck is saying he wants to show a cable out of the panel to a downstream load, and specifically to a transformer. So that's a real good point. So I'm going to move this over. Actually, I'm going to delete it. One of the disadvantages, that's a good point, Chuck, thanks. One of the disadvantages of using the icon is it shows, when we calculate instant energy, it's showing the calculations for the main bus of the panel and the MCC itself. And so very often it's going to exclude the main when we're, and that's why I used the main lug only. If we connect a load downstream so we can see what the distributed instant energy is, or for whatever reason we want to do that, let's go ahead and set up a two-winding transformer. Let's put a cable to that. Again, these are three-phase loads right now, but the same mechanism can be used to do single phase, which I'm not going to get into. And for now, let's just put a plain bus. Let's make it 208. Let's make this a 125 kVA and 3% impedance. Now, all I need to do at this point is size the cable and then indicate the connection point for this transformer inside my panel. So let's make this 50 feet long. Let's make it THHN. And just for grins, let's do a 2-aught. Now we see this is coming in or going out on C3. So if I open my panel schedule back up and look at, so it looks like we have some room here on the right side. So I'm going to indicate this is a subsystem or sub panel. I'm going to tab over. It says I need to show what the line is connected to. So it's C3. I want to show that it's a three-phase load. Now, and this is why this is a great question. The parameters for the load are coming off of the one-line diagram, not included in the, I mean, these numbers have been picked up now based upon the cable and the loading of the transformer. And so be able to size the motor control center, the molded case circuit breaker, rather than populate it like I could here, I use the data block to populate it. And we want it to be a, say, a generic 150 amp thermomagnetic. I want to make sure it's calculating. And it is. Let's set a phase trip up. And now I'm good to go. I want to make sure I've included that now in my summary. And then, I don't remember what we did to this side. Problem with short circuit. Oh, we got some problems in our panel schedule for panel 2. But at this point, once I clear this up, I'll be able to then have a panel for, where's panel 2? Details. All right, let's go back to short circuit, fault the bus. And now if we look at the tripping mechanism for this one bus, it'll indicate the feeder, or at least whatever upstream breaker is tripping, and to make sure it's correlated, we'd want to size the breaker inside the feeder on this panel, so this tripping before our main feeder breaker is going to trip on the fault. Okay. Hopefully that was helpful. Thank you for the question. We've kind of extended the topic that I wanted to talk about. When we post this video, there'll be a zip file on that same link, and you can download it and unzip it to your templates folder, and it will give you the ability to select ArcFlash MCC schedule and ArcFlash panel schedule. So any questions, well, let me know. And again, just to, install it in the templates folder. So again, whether it's useful or not, we've discussed the pre-configured capabilities of EasyPower, custom schedule templates. You're welcome to customize your own version if you have needs outside of just the ArcFlash. All this is described in the user's guide. One more word from the sponsor. You're more than welcome to submit ideas for refresher topics and topics for technical presentation on the Thursday webinars as well. Thank you all attending. I'm going to have another question here. Let's see if we can. It says the template showed calcs in, yes. So the question from Frank is the template, the ArcFlash showed calcs in calories per square inch, and that was a typo because that's text that's entered in the, and I'll fix that before we post the files to the website. Thank you. Thank you all for attending. Welcome contact if anybody has questions, and we look forward to talking or meeting you again online down the road. Have a good day.